Well, the top's just going to go to a 1. I'm going to put the bottom as that quantity to the 1/2 power, just getting rid of that radical symbol, making it a fractional exponent. Now I can see I can slide it up to the top and make it a negative exponent. So I've got x squared minus 2 to the negative 1/2. So I took something that I could not do derivative of, and by doing a little simplifying, manipulating, we got it to something where now I see an inside and an outside. So a little chain rule. So I've got negative 1/2 comes down, times inside stays the same, to the 1 less power, that's going to give me negative 3/2, times the inside derivative. The inside derivative is 2x. Derivative of the minus 2 is 0. Now I will take the time to bring this to the front because I do get to see some simplifying that's going to happen. So because things are going to combine here, I will bring it to the front. This last example, if I brought this to the front, nothing was going to combine other than me distributing in. So half of negative 1/2 times 2 is going to give me a negative 1x times my quantity x squared minus 2 to the negative 3/2. Okay. Again, it's just getting it in the form where we can do the derivative rule. We've got 1 over 2 times the square root of t minus 3. Okay, I'm going to get rid of that radical. So the t minus 3 is to the 1/2 power. The problem with this is that t in the bottom, I can slide that to the top. The 2 is just going to stay down. So what I'm actually going to have is a 1/2 times by this quantity t minus 3 to the negative 1/2 power. So I've left the 2 in the bottom. The 2 is not the problem. It's the t that's got to get up there. So I take that whole quantity by making that exponent negative. And now I can see this 1/2 is just a multiplier on the parentheses, so it's just going to carry along. I'm going to work with it, and I'm going to do inside, outside. Start here. So the negative 1/2 gets multiplied by the 1/2. That's going to give me a negative 1/4. The inside stays the same. Subtract 1 there, I'm going to have negative 3/2. Times by the derivative inside, the derivative of t is 1. Derivative of minus 3 is 0. So I didn't even need that. So there's my derivative. Let's do a few more trig ones before we're done here. 1/2 sine to the 1/2 3x. And again, anytime I see that exponent on the trig function, I know that's a set of parentheses that mathematicians were too lazy to write. So I'm going to take the time to rewrite it with the parentheses. So it's the sine of the angle that's to the 1/2 power. This 1/2 is actually around the trig function with this angle. Now I can easily see an inside and an outside. This is the farthest thing out because this one has an inside and an outside within it. So we've got a couple chain rules we're going to have to do here. So starting on the farthest outside, that's this power. So power rule says multiply it down. That'll give me 1/4. Keep the inside exactly the same. To the 1 less power, that's going to give me negative 1/2. Now I'm moving to the inside here. Inside, I've got a trig function with an angle. This is my outside. This is my inside. So, starting with the outside trig function, the derivative of sine is cosine, 3x, times by the derivative of the angle, derivative of 3x is a 3. So this 3 should come to the front and make 3/4 sine 3x to the negative 1/2 cosine 3x. So I'll bring something to the front if it's going to combine with something that's already up there. How about cosine of 4x to the 3/4. Okay, now with the 3/4 here, this is only on the angle, not the trig function. See the difference here? It's next to the function when it's a set of parentheses around the whole trig function. Here it's just the angle. So this is my inside function. Here's my outside function. So I'm ready for derivative right now. Derivative of cosine is negative sine. Keep the angle exactly the same. Times by the derivative of the inside. The inside is this angle, this whole angle. Well, this angle has an inside and an outside. So I'm going to start out here with the outside. So this 3/4 is going to come down, get multiplied by this, keep it the same, to the 1 less power. That'll give me negative 1/4 when I subtract 4/4. And then times the derivative of the final inside. Derivative of the inside is a 4. So all of this, I can combine the 3/4 and the 4. And I should bring it to the front here. So anytime we got a trig function, because we don't want this to get confused with the angle here. So all of this is going to come to the front, this whole group. Get multiplied by the negative 1 that's out there. So I'm going to have, let's see, the 4's are going to cancel. So I'll have negative 3 times 4x to the negative 1/4. I can't multiply the negative 3 and the 4 because the 4 is trapped inside of those parentheses with that exponent. So then sine of 4x to the 3/4. Those are a little tricky, but the more you do them, you will get very good at them. Okay, last one. We're going to write the equation of the tangent line to the graph at the point. So our function is the square root of x squared plus 5, and we want the equation for the tangent line at the point 2, 3. Well, if you take a quick look at the graph, clear, square root and we're concerned about the graph right here. So we've got this going on. I'll come over here. So at 2, this thing's up at 3. 1, 2, 3. Okay, our goal is to come up with the tangent line at that point. And then the thing to remember, the tangent line looks like this. It just skims the graph there. That the slope of this line is the derivative at this x value. So slope is equal to f prime at the x value of 2. So we're going to find the derivative function, f of x, f prime of x, and then we'll plug the 2 into that equation. That'll give us our slope. So I'm going to rewrite f, so it doesn't have the radical, x squared plus 5 to the 1/2 power. Now I can see inside, outside. That should be getting very obvious to you. 1/2 comes down. X squared plus 5 to the, if I subtract 2 over 2, I'll get negative 1/2. Inside, I've got a x squared, so derivative is 2x. Derivative of 5 goes to 0. Just simplifying, bringing this to the front because the 1/2 times the 2 does simplify down to 1. X times x squared plus 5 to the negative 1/2. So now I can find f prime of 2 by plugging 2 in there. Let's see, that is 2. Negative 1/2 power means it's down there in the bottom of square root. That's 9 square root of 9. 2/3. So the slope of that line has a rise of 2, run of 3, rise of 2, run of 3. Now I just have to find the b value. I don't know exactly where that crosses, but I can find it. Just squeeze it in here. Y equals mx plus b. We've got an x and a y on the line. We have the m now, so we can find the b. So y is a 3. M we just found was 2/3. X is a 2. I'll make it 2 over 1 plus b. So that's going to be 4/3. So if I subtract 4/3 from, that'll leave me with b. So that will be 9/3 is still 3. Common denominator, 3 over 1. 9/3 minus 4/3 is 5/3. Sorry, that's getting squeezed in here. So my equation for that line is going to be y equals, the m was the 2/3, way over there, over there. So 2/3 x, and the b that's going to cross at 5/3 plus 5/3. Okay, and you are going to have a worksheet. The problems we're going to do, I guess I'll write them out in case you take the worksheet early. You are going to do, let's see, 7 through 15 odd, 19 to 33 odd, 41, 45, and then the 5 trig problems that I wrote on there. Okay, good luck with your chain rule.